Hello, wonderful Advanced Algebra 2 students. I'm going to teach you how to solve radical equations. This is the first of 2 videos with radical equations. And remember, our goal when we solve any equation is to have our answer isolating the variable. So our goal for our equations is to have x equals some number. And that could be one solution of x equals, it could be 2 solutions of x equals. So for our first day of notes here, I'm going to have 3 examples where we solve radical equations. Our next video will have us solve equations with rational exponents or fractional exponents. Here's example 1. Solve 2 times the quantity the cubed root of x minus 3 equals 4. So our first step to solve this radical equation is going to be to isolate the cube root expression. And in this example, we'll divide both sides by 2 to isolate that cube root expression. So we have the cubed root of x minus 3 equals 2. Then we're going to use undo operations to solve or isolate for x. So I will cube both sides. The opposite of cubed root is cube. X minus 3 is on the left side of the equal sign, and then 2 cubed is 8. So we have x minus 3 equals 8. I'll continue using undo operations by adding 3 to both sides, and I get x equals 11. That is my final answer. I could check my solution by inputting 11 back into the original cube root equation. So if I input 11 for x, I would have 11 minus 3, which is 8. The cubed root of 8 is 2 times 2 equals 4. That's how you can check your answer. So we just solved a cube root equation. Example 2 is a square root equation. Solve the square root of x squared minus 2 minus the square root of x plus 4 equals 0. So my first step, just like the previous equation, to solve this radical equation, I would isolate the square root expressions. Wait, but we have 2 square root expressions, so to isolate them, I'm going to add the x plus 4 square root, x plus 4 square root to both sides. Then I'll have the square root of x squared minus 2 equals the square root of x plus 4, so they're isolated. Use undo operations to solve for x. So the undo of the square root would be to square both sides. I'm left with x squared minus 2 on the left. Square both sides. I'm left with x plus 4 on the right. I'm going to continue using undo operations, and I notice I have a quadratic equation left over in this example. So I'm going to subtract x from both sides. X squared minus x minus 2 equals 4. I'm going to subtract 4 from both sides. X squared minus x minus 6 equals 0. The reason why I chose to do those operations is because to solve this quadratic, when I have an a, b, and c value, I have to first get this quadratic in standard form. Then I'll try to factor, or I'm going to have to use the quadratic formula. So with this quadratic in standard form, I believe it is factorable. I'm thinking of two numbers that multiply to -6 and add up to -1, and that would be -3 and 2. So I factored the quadratic. Now I'm going to use the zero product property to solve. So I set each factor equal to 0, because the whole quadratic expression is equal to 0. And I have x equals 3 as one solution, and x equals -2 as one solution. Now, because this is a square root radical, and the square root graph has a restricted domain, unlike the cube root graph that continues forever and ever in both directions, the square root graph is restricted. So I have to have a step 3, and I have to check for extraneous solutions. I know you remember that last semester. An extraneous solution is one that you get algebraically, but when you input those values back into your original equation, it's actually not a solution, it's extraneous. So we have to check for extraneous solutions, and we do that by inputting 3 into the original equation and then inputting -2 into the original equation. I'm going to start with x equals 3. That would be the square root of 3 squared minus 2 minus the square root of 3 plus 4. Let's see if that equals 0. So we'd have 9 minus 2 is the square root of 7 minus 3 plus 4 is the square root of 7. Does that equal 0? Yes. So x equals 3 is a solution. Lastly, I'm going to check -2, see if that's an extraneous solution. So I input -2 for x, -2 squared minus 2 minus -2 plus 4, and we'll see if that equals 0. So we have 4 minus 2, square root of 2, -2 plus 4, square root of 2, and does that equal 0? Yes. So for this square root equation, this radical equation, I have two solutions, x equals 3 and x equals -2. Done. Let's have one more example of a square root. And remember, square root has restricted domain, so we have to check for extraneous. Let's do one where there is an extraneous solution. Last example. Example 3. Solve the square root of 2x minus 5 plus 4 equals x. Now remember, this is a square root, so automatically I know I'm going to have to check at the very end, but the first step is the same. Step 1, isolate the square root expression. We'll subtract 4 from both sides to isolate the square root of 2x minus 5. Step 2. Use undo operations to solve for x. Square both sides. So I have 2x minus 5 equals the quantity x minus 4 squared. 2x minus 5, expand x minus 4 squared to x minus 4 times x minus 4, and then double distribute. So 2x minus 5 equals x squared minus 4x minus 4x plus 16. 2x minus 5 equals x squared minus 8x when you combine like terms, plus 16. And I have another quadratic equation here, so I'm going to set this equal to 0, turn it into standard form by subtracting 2x from both sides and adding 5 to both sides. I'm going to do both steps at once. So I have 0 equals x squared minus 10x plus 21. So now that I'm in standard form with this quadratic, I'm thinking, can I factor this, or will I have to use the quadratic formula? And for this quadratic equation, I can think of two numbers that multiply to 21 and add up to negative 10. That would be negative 3 and negative 7. So x minus 3 times x minus 7 is factored. I'll use the zero product property to solve. X equals 3 is the first solution, and x equals 7 is the second solution. So last step, again, because this is a square root radical equation, I have to check for extraneous solutions with that restricted domain. Check for extraneous solutions, third and last step. So I'm going to check 3 first by inputting 3 in for x. That'll be 2 times 3 minus 5 plus 4, and does that equal 3? The square root of 6 minus 5 is 1. Is 1 plus 4, the square root of 1 is 1, equal to 3? No. Therefore, x equals 3 is extraneous. It is not a solution. Now, if I could say negative 1 here, then it would be, but no. The square root of 1 is positive 1, and positive 1 plus 4 is not 3. So x equals 3, although we got this solution algebraically, it is not a solution. It's called extraneous. Let's check 7. Input 7 in for x. And we have 14 minus 5, which is 9. Oops, 7. I'm putting 7 in for x. So 14 minus 5 is 9. The square root of 9 is 3. And 3 plus 4 is 7. Yay! So 7 is my one and only solution. Now, if, for example, both solutions that you got algebraically came out being extraneous, then you would say no solution, which you may see in some of your example problems. So feel free to rewatch this video, ask me any questions through email or Zoom chat, or a Canvas chat or a Remind chat. Slow down the video, speed up the video, whatever you need to do to learn how to solve radical equations, make sure you do it and submit your homework. Have a great day.